Who is a long term friend of Rajat Gupta? Raja Ratnam is mentioned as a long-time friend of Rajat Gupta, provided the context. Raja Ratnam. Where is this guy? You see, Raja Ratnam is a long-time friend. So, today I'm going to discuss about the PDF chatbot architecture with RAG. So we are building a chatbot on top of a PDF. So the PDF document is the source, and on that particular PDF document, we will build the uh, detailed chatbot. So here is how the flow goes. So we have the PDF document, and we cannot upload all the PDF document to any AI model every time. So we need to clean the PDF document, and we need to do small chunks, and those small chunks, by using embedding model, we convert those into the vectors, and these vectors we store in the vector database. So we are using Qdrant as a vector database, and once after storing the vectors, we will use a retriever, find the relevant chunk based on our keywords, and we get top k value. For example, k is 4. We take top 4 values, top 4 vectors, and with those 4 vectors as a context, and we will have a user question as well. With the user question, we give that to GPT-4 or GPT 3.5 model or any LLM model, and the LLM is going to answer the user's question, and we show that in the front end. So here if you see, we have the backend APIs as a backend as a Python APIs. It's on fast APIs, and front end React application, and it's user. If user asks a question on front end, it goes to the backend, and in the backend, it with the retriever, it will retrieve the most related chunks from the vector database, and the top 4 chunks is given to LLM model, and LLM will answer the question. The answer is shown to user. So that's how the whole flow goes on. And let's jump back to the real-time application. Yeah, let's see about the PDF document we got. I took the business ethics textbook. This PDF document, it has a lot of pages, like 377 pages. So we need to break this whole PDF into chunks and then store it into the vector database. So here our goal is, for example, if I ask who is Raj Gupta in the ChatGPT, since ChatGPT doesn't have any context about the textbook, it took the source from the Wikipedia and gave about Rajat Gupta. But if you see here, the Rajat Gupta, this particular line, Rajat Gupta grew up in India and an MBA Harvard and processed something blah blah blah, managing director of a company. So this particular, if I ask this question to ChatGPT, it took the source from Wikipedia and answered. But for our chatbot, if I ask the same question, it needs to take the source as this one and give us the correct answer. So that is our end goal. Okay, let's jump into the code. That's the first and important step here is, so we have gone through the PDF document. Now we need to vectorize that and store the vectors into Qdrant. So the ingest PDF Qdrant, this file is responsible for doing that. The first step here is we are loading all the imports. We are using PDF loader for loading the PDF, and Hugging Face embeddings for creating the embeddings, and Qdrant for vector store. Qdrant, it's a database, so Qdrant client is for connecting the Qdrant, and recursive character text splitter is for splitting the text, and the next 13th line number 13, the first step is to load the environment variables. In the environment variables we have this open API key and Qdrant API key and Qdrant URLs, and any other environment variables we can add there. And after that, this is the path of the document. So here, if you see, in the utils, I downloaded the whole text and added it in the utils folder. This is one way of giving the source data, or you can connect to database, or you can connect to any other APIs, and you can get data from the APIs and chunk it and vectorize that. So there will be multiple ways to get a data. And the collection name, in the Qdrant, we need to create a collection. The name of the collection that I created is AI_tidings1, and we got the PDF, and we are using embedding model to create embeddings, sentence transformers all mini LM L6v2. So this is the model that we are currently using. The other alternate for this one is OpenAI also have a embedding model, but I believe it is going to charge something. This one is free. It's in Hugging Face. And the next one is ensure collection. So we can create a collection directly in the Qdrant cloud. If there is no collection, then it will create a collection with cosine for cosine embeddings. And if it is already have the collection, then it is going to use the same collection and update these vectors. Client.create collection, this is used for here. So if you see, this is distance is cosine. So the vectors are stored with the cosine distance, and after that, okay, PDF part exists. Now we need to connect to the Qdrant URL. Qdrant URL, we are getting the URL from the environment variables and the API key and other detail. API key also we are getting from the environment variable. And the line number 50, we are loading the PDF file here, and we are storing it in the docs variable. And splitter, we are splitting the docs into chunks. The chunk size is 1000 and overlap is 200. I will create one more video what will happen if I increase the chunks and if I decrease the chunks and overlap, chunk overlap, and I will create another video. And coming to 58, currently we are using Hugging Face embedding model, and we have this initialization of embedding model, and created a Qdrant client. This is for you giving the URL and the API key as a Qdrant client. We have this one, and we are determining the vector dimensionality. We have the embeddings, right? So we are basically just using embeddings that client that gets sentence embedding dimension, and it's just a print statement to know the collection name and vector size. So here this is the main thing. With Qdrant, we are storing all the chunks here, the chunks and the embeddings and Qdrant URL and the Qdrant API key, and collection is collection name. And so we are going to write all the chunk embeddings into Qdrant via the LangChain's vector store. So this is the key thing. how we store all our chunks into Qdrant. This is how the Qdrant look like. This is the cloud Qdrant. This cloud.quadrant.io, it's free, and the free tier comes with 4 GB disk, 1 GB RAM, and 0.5 CPUs. I think this is enough for learning. And if I open this one, so if you see, we need to create a Qdrant API keys here. This is my API key, and we need to store it in environment variables, and it will give the Qdrant URL as well. So these are the different dashboards, markets, logs, and backups and configuration. So this is just a Qdrant cloud. So the main key thing here is if I open the cluster UI, I need to open it. Okay. Yeah, here it is. So if I open the cluster UI, I have AI trainings 1. So I have 1525 chunks. The whole PDF is divided into multiple chunks and stored here. And we are using the cosine similarity for distance calculator, and take a snapshot, visualize. If I go here, and this is the detailed one, the collection info. I will explain. Maybe I think I need to create a separate course on the Qdrant. But on the high level, this is the user interface, how Qdrant look like. The key thing here is we just create a collection, and where I run the Python code. So and after running the Python code, it created a collections, and then it created chunks. So I'm going to explain the Chatbot server code step by step. So this Python, these are all the import things. Currently we are using .env, fast API, and OpenAI, and LangChain and LangChain Qdrant. We are using VectorDB as a Qdrant. VectorDB as Qdrant, and we have the Qdrant client to connect to the Qdrant database. And next thing is load.env. This is for environment variables. So we stored this Qdrant API key and Open API key and the other URLs in the environments. I'm not showing the .env. This is the example .env. And once we load all the environment variables from .env, this fast API, we are creating a REST endpoints with fast API, and I'm giving this is a basic regular cross origin request. My server, my front end is running on a different port, and server is running on a different port. To restrict cross origin request, we have added this one, and we are getting Qdrant URL and Qdrant API key and the Qdrant collection. The name of our collection is AI trainings, and we are using the embedded model as sentence transformer all mini LLM L6 v2. So this one we are using it from the Hugging Face. I can explain more detail. I will create a more detailed video on this embedding models. We can use the OpenAI embedding model also. I think that's going to be paid version. This is the free one, and these are all Python classes. This is a regular health check API, and the next one is vector store. Yeah, if we go to the main thing is chat endpoint. So the chat endpoint, we are getting the Open API key here, and we are creating an OpenAI client with the API key. And for the client, and we are getting the user question for we are getting the latest user question. It may be question or message from the user messages. And the vector store, we are getting the vector store, top k relevant chunks from the. So this vector store is used to get the so we are initiating the vector store, and we are doing a similarity search on the vector store with a query text and k is equals to 4. This is the top k value. So we are getting 4 chunks from the vector store with a similarity search. With this similarity search, these are all the different things. I'm going very minimal. I'm not using any filter, search params, all these things. Just a query and k is equals to 4. And I will, here is the context. After getting that, all the docs, I'm setting the context as this docs. And now if you see this message, content, use the provided context to answer. If the context is empty or irrelevant, say you don't have enough information. So this is the basic plain prompt engineering. Here the prompt engineering comes into picture. So you need to clearly add more detailed and specific prompt for your use case. Currently we are just learning, right? So this prompt is sufficient for our use case. And the next step is we are using the OpenAI client to call that model with our message, and we set the tokens and we set the temperature. Okay. So this is the code base. So I discussed about the front-end React application, Python API server, and ingesting the ingesting the PDF document into vector store. Now let's see how it works in real time. Let me ask a question. Who is Rajat Gupta? Oh, it's still sending. Maybe I still need to get it. Let's go and look at the logs, what it is happening behind the scenes. So the application startup completed. If you see option/chat, we got the API call here, and I think it is getting the vectors. Let's give it a moment. I don't know, for some reason it is very slow. Maybe I am running multiple servers here. If you see, it called the vector store, it called the Qdrant, and retrieved docs. It got all the docs. Let me maximize this one. So it called this is the vectors that it got pulled. If you see here, a document, these are the different, I believe 4 chunks. There will be 4 documents. Okay, I think it is done. Let's see what it answered. Rajat Gupta is a former managing director of McKinsey Company and respected business dealer and co-founder of Indian Business School, American Indian Foundation. He was convicted for felony fraud, security, insider trading in 2012. Let's go and cross verify here. So Rajat Gupta grew up in India, MBA from Harvard and managing director of McKinsey company, founder of Gupta served many. Let's see who is a long-time friend of Rajat Gupta, if it answers or not. Who is a long-term friend of Rajat Gupta? Raja Ratnam is mentioned as a long-time friend of Rajat Gupta, provided the context. Raja Ratnam. Where is this guy? You see, Raja Ratnam is a long-time friend. So the first question it took a long time, but second question it took very shorter time because we are caching those vectors. I think that's it about this. So just reiterating, we took the PDF document with the help of embedding model. We created chunks and stored the embeddings in the vector storage, and with the help of a retriever, top k as 4, we retrieved 4 best matches based on the user question and asked LLM to answer our question, and LLM answered. We have showed this in the front-end React application. I think that's it for today. Thank you. If you have any questions, please post it in the comments. And please don't forget to like this video, share this video across your friends, and please subscribe. Thank you. Thanks.